Let's have a look at module now. Module is a Python file consisting of definition and statements. So it can define function, classes, variables, and also include runnable code. It is very useful to reuse and share the code. So it's very easy. If you have to define a module, you can just create a Python file and then just write a function definition or variables, whatever you want to do. So before we define a module ourselves, let's call a couple of modules which are already there. So there is a module which is math. So we will just call this entire math, we will include it, and then we will declare our variable pi using math.py. So till now, whenever we were supposedly to use pi, we have used value 22 by 7, but now we can directly import its value from math. So let's print it and see what is the output. So you can see the value is 3.14 and so on. Now, if you don't want to include you don't want to import the entire package or the module, then you can just import specific attributes and functions. So for example, rather than calling in entire math, we will say from math import pi. So that means we will just import this particular attribute and then we will print it. Okay. Now let's see if we have to create this module. It's very easy. Just create a Python file and then if you whatever variable or function you want to write, just add it there. So let's see. I'll create a simple file. I'll create a text file and convert it to Python. So I'll create a text file and I'll call it say sample module. Okay, and then I'll end it with .py so that it becomes a Python file. Okay, and let's open it with Notepad and just add it. Open with Notepad and just add a function there. So say I'll say definition sum ab and say a comma b are two parameters that will pass colon and then return a plus b. Right? Very simple function that we have added here. Now let's save it and close it. So first we'll import sample module in our file. Let's do that. So we'll include import sample and module and then say we will say we want to call the function sum ab and we will pass it to values 2 and 3 and let's say print. Okay, so now we already have a print function, some ab function defined in this module. We have just imported it and then simply reuse it by calling it into our code. And before we call, we have to just add sample module dot so that it knows that this particular definition is present in sample module. So with that, let's run the code, shift enter, and you will see the output is 5. So it's pretty easy, right? We have learned how to create a sample module and then also declare a definition within it. Now there's a quick question. Let's see if you can do it. So the exercise is create a module 1 and then write a function square root and then call it to get square root of 100. So you should be able to call this particular module and then to the square root. So just as we have done for the sum, I hope you can do the same for square root, right? Just create a file module1.py, have a definition square root, and then just return exponential of 0.5. So with that, your Python module is complete. Now you have to just import it into the code and then print module1.square root 100. So we can just reuse the same code and what's the name, module 1. Okay, so module 1 and then module 1 dot. It's pretty easy. I'm just doing it so that you get a little more confidence, but it's super easy. And dot square root, whichever number you want to provide. So square root and say 100. So we'll see the output is 10. Okay, pretty easy. Now with that, we know how to create our own module on PC. If you want, I've just written here so that just create a new Python file with extension py, write the function, say square root, save the file, import it, and then call the function. We did using the notepad, but please note you can also do the same using creating a new Python file here itself, right? So you can create a new Python file and then save it on your machine. So then just download it as the Python file. Okay. Well, so here's a quick example where we have used input to get radius from the user, and then we have used 22 by 7 as the value. Rather than that, this time we can actually use the actual pi value from method.py. So let's run it. Say we'll enter the 7, and this time you'll see the output is 153.93 because we have used the actual value, not 22 by 7.